We here in the back? Are we okay? So, first off, I did not realize that Amit was going to be looking at pictures. So, yeah, I realize I am not prepared for this. And yet, this is the same jacket, but I want credit. This is a brand new shirt, okay? So next year, even though I'm not in the picture, this is new. So I just want to point that out. And I heard that Adam had a very amusing thing yesterday highlighting.
It was Google.
Was it Google or Alexa? It was Google. Okay. Well, I am back at UT, and but I'm still working with the OpenHPC project, and I thought I'd just give a quick overview. And as I've talked about this for a couple of years now, and mainly after the overview, kind of highlight things that are new since last year, things that perhaps might be of interest. And then, because we have a pretty technical audience, I'm going to try to dive into some fun with packaging, and I think it might potentially have some relevance to mVapich as well, and so we'll dive into that, and hopefully you won't kill me for talking about RPM too much. So just the quick sort of introductory couple of things about OpenHPC. If you're not familiar with it, we've been around for a couple of years now, and just the first thing to recognize from the mission point of view is that we're trying to provide a reference collection of open source software, and really trying to leverage a lot of the best practices that many of us at supercomputing centers around the world have learned over the years, and I'm very guilty of having learned the hard way and iterating over many years. So this is really just a community effort to try, if possible, to minimize the amount of reproduced effort that happens across sites around the world. So you can see our mission and vision. Really the thing to highlight here is that we are trying to sort of combine points of view from lots of different places. End users, like Amit just talked an awful lot about people doing science. They don't care how the software gets installed, frankly. They just want to know that PETSI is there and that HDF is there and that it just works. But also, at the upstream of that, we have developers like the folks here at Ohio State who are providing a lot of the software in the middleware that gets used by those end users. So it really is a combination of a community of folks in terms of users, developers, administrators, and vendors as well, because they're important in terms of providing hardware. In terms of project membership, so highlighted this last year. We've had a number of new folks join since last year, so just highlighting those in the boxes here. Several universities from New Mexico and Rutgers, and National Lab, NREL joined a couple of companies, including Bright Computing, QCT, and Huawei. And I know we have talk here somewhere, I see. So happy to have them on board, and this has been growing. And just the quick spiel here is, if you're an academic or a national lab, there's no cost associated with this. We're doing everything through the Linux Foundation, which is a nonprofit that we work with in the US. In terms of how we manage things, just one quick thing to highlight, that we have this is a community effort. It's not just me. I'm going to show you the steering committee on the next slide. But we sort of have a governing board. We're split up into a governing board and a steering committee. The main thing to highlight here is that this steering committee is from volunteers. We very much appreciate people's help, and you don't have to be a member of the project to be on the steering committee. And I just wanted to highlight that now that we've sort of reached this steady state of operation, we are taking nominees for steering committee members every year. And we do this basically in the summer, so it just happened. You just missed your opportunity. I'm sure you were dying. I know Karen was probably really upset that she missed it. But just want to let you know, should you be interested, we do take nominations at the beginning of June. And we just went through this, and so we have roughly 20 folks participating on the steering committee. The folks you see in blue are new this year. Just want to highlight that we want to try to get new folks in, but also have some of the older folks, so that we have a continuity with the project. We have a couple of new folks from national labs in the U.S., from some academics and some industry folks as well. So just want to let people know that we do have a steering committee that helps really guide everything in terms of architecting how the packaging is done, putting out releases, and doing the day-to-day work. And the last One more quick thing about overview. I think everybody here, we all know what we're talking about. Nothing has changed from our perspective from OpenHPC in terms of the target architecture. We're trying to give people software tools, both from an administrative point of view and like in user libraries, numerical libraries, I/O libraries, etc., that they can use on bare metal. So we are targeting bare metal. Obviously, there's a huge push these days to do things in containers and in virtualized environments. So there's nothing preventing people from doing that. And we see a lot of folks pulling stuff onto EC2 and Azure and the like. But from an installation recipe point of view, what we have been targeting is a bare metal install. We assume you have some out-of-band network with which you can power nodes. We assume there's some sort of high-speed network with which you do MPI, our bread and butter. We do target a couple of parallel file systems. Today, that's Lustre and BGFS. And in terms of the MPI fabric, that we sort of test on today, it's InfiniBand, OmniPath, and Ethernet. And I've showed this before. There's really no change. The only thing that has been new this year is, strangely enough, we really just targeted sort of high-speed fabrics. And people asked us for recipes to do Ethernet only as well. So we've make it a little bit easier to do that at the same time. So if you don't know anything about OpenHPC and just walk away with one key thing, just know that it's a software repo. Yes, go ahead.
In the last slide,
yeah.
What the green represent in the parallel file system?
This green here? This is just highlighting, for example, think of a Lustre file system where you have metadata storage targets and object storage targets. It's just highlighting the fact that a parallel file system is distributed and you use multiple servers to build up the parallel file system. Yeah. So and we're not. So what we've been doing is providing clients for the parallel file system. Those of us in the room who have set up GPFS and Lustre and all these other things will know that that's a non-trivial exercise to build this in and of itself, and often the parallel file systems have lifetimes that are different than the HPC system. And so what we're doing is providing clients so that if you have a parallel file system, you can add it here. Yeah, and please feel free to ask questions along the way. So I was saying on this slide that the takeaway is really that OpenHPC is a package repository. It's a software repository, and I mean repository in the truest sense of the word in terms of package managers. So we have public repos for a couple of different OSes, so you can interact with it with yum and zipper. It is intentionally meant to be building block oriented, so right, if you're not on a bare metal system, you don't need provisioning capabilities and you're going to use EC2, for example, to build an image, that's fine. You could still pull in Imvapage and all the other parallel libraries that you might want to use with it. So you can pick and choose what you want. All right, so that's really kind of a high-level takeaway. So now I will switch gears and just highlight some newish items since we were together last year when I was not wearing this sport coat, but I get no credit for that because I missed the picture. One thing that's new is I mentioned the architecture and that we are targeting bare metal environments. So in addition to being a package repository, one of the things that OpenHPC provides are installation recipes that if you're standing up a new system, you could follow them to stand up the system from scratch. And when we started back in at the end of 2015, we had only one recipe. But we always thought that we would sort of grow that. And in fact, that has happened. So as of the last release, we're up to having 10 different recipes. You can see here the notion already that we're supporting multiple architectures, so kind of organize these recipes by architecture for x86 and ARM. And we also organize these based on high-level choices that an end consumer might make, so a site who's deploying an HPC system. And that's around things like provisioning, what kind of provisioner you might want to use, and resource management. Right, and the reasons these are organized independently because you really wouldn't have two provisioners or two resource managers on the same HPC system at the time. That doesn't make a lot of sense. So the thought that sort of the direction we went is that the site administrator picks one of those and then they can pick one of these installation recipes and follow it. And we spend an exorbitant amount of time trying to validate these recipes and automate testing all of them. So in fact, the fine folks at TAC are kind enough to host some cluster infrastructure for us where we test all these things. And when I looked maybe a couple of months ago, the x86 clusters have been installed like, I don't know, 13,000 times or something like that. It's a good place to test hardware if you want to see it getting beat up. But this is, we've grown this, so there's a lot more to recipes. And the things that are new from last year are, we have a stateful example with XCAT. If you're in the provisioning business, you tend to make a choice as to whether you're stateless or stateful. And it's kind of a religious choice, yeah.
Can you please clarify what stateful and stateless means?
Yeah, so the question is, what is stateful and stateless? So the traditional stateless approach is that you don't write anything really to the disk on a compute node, and you push out a very small image, and very often that image resides in a RAM disk, right? And so it's stateless in the sense that if you reboot, there's nothing left over on the node. And the counter is stateful, where you actually physically provision packages onto either a spinning disk or some sort of I/O disk that's sitting there, and that way if you reboot, you have state. So TAC is a stateful place. Some of the national labs tend to be stateless. Yep. And then we've also sort of grown the testing in the ARM side with the inclusion of PBS Pro. So that's one change. Another change is folks asked us if we could support rsync, which is a very reasonable request. So we support rsync now as well. And just to kind of highlight the different methods that are available from a package repository point of view. So I already highlighted, you can talk to our repositories directly with Yum and Zipper, but obviously you have to have external routing from your cluster. And if you're at a lab, there's probably, I don't know, I'm guessing, Adam, you guys don't support such a thing. So you probably mirror things locally. And we know that that's the case, so you can download a tarball from OpenHPC, which allows you to mirror everything locally, and we just enabled this new business where you can do things with rsync, so you can just pull down deltas. So that's new since we were here last time. Yeah, go ahead.
Actually, like an unrelated question to RTMs. So suppose the module you are building depends on some other module, which is installed on the system. But it may be installed at different locations on different systems. So for instance, somebody might install it user local, somebody might install it /opt, somebody might install it /cm apps,
right,
things like that. So if you are building a package which depends on such a package which can change,
right.
So how do you go about it? How do you create one RPM so that can you add a prefix option, or so how do you go about that?
Yeah, so I mean, the question is really about trying to build and deliver packaged software where you don't know in advance where some of your dependencies lie, right? And that's a non-trivial answer. I can't give you a quick one. In fact, I will say, the other complication is also there's the way that the distros do it, which the distros do it by saying you don't put them in opt, right? All roads lead through bin. All roads lead through /lib64. The linker sees everything, and they solve it in a way that isn't exactly what we want from the HPC, right? Because we want to have 15 different versions of Mvapage installed, because one of them is awesome, right? And other stuff too, Intel compiler versions, because only one of them works with my version of the code, right? So we have this additional problem, if you will, that we both want and create, which is that we want multiple versions of the software, which is why we also then tend to adopt some sort of user environment that the distros like modules, right? And so OpenHPC sort of has jumped in 100% with modules. So the way we handle that is to say that you are going to figure out where those things are that you need by loading the right module. And we manage all the dependencies, but the dependency management is also a separate headache, which is going to be the end of the talk here. Okay. So I can't give you there's no magic, but there's some things you can do.
Okay, thanks.
Yep. So I did also want to just highlight sort of the release cadence that we've had and talk about how many things change in the HPC community. And DK kind of highlighted this in his comments just a little while ago, is that HPC software changes pretty rapidly. And part of the motivation for a community effort like OpenHPC is to try to adopt that change and make it available to a larger audience in a reasonable amount of time. So reasonable for us is at sort of a quarterly cadence we've been doing. These are all the releases we've had since the project started. and it's been roughly quarterly. And really the convention that we have taken is that we sort of assume if there's a new upstream version of a component that we're packaging, a new stable version, we go with that. We always go with the latest, greatest, unless there's a reason not to. So for example, MVAPitch 2.3 is out now, right? We have that spun up on our build system. It'll show up in the next release. That's kind of our convention. If something breaks horribly, then we might walk away from that. But that's what we do. And we also add components over time. So the plot on the left-hand side is just kind of highlighting how, the growth of the number of components in OpenHPC since the beginning. So we have something like, a little over 80 components now. And I talked last time about, how we get stuff added to that. And then on the right-hand side, though, what this is trying to highlight is a measure of how much stuff changes in our HPC field, essentially on a quarterly basis. So what this is telling us is for every release, what percentage of components had new versions at that particular time, right? And you can see that on average it's somewhere, say in the last year or two, between 30 and 40%, something like that, right? So it tells you like we're having to, and that moves, right? I mean, all the time. So something like Slurm, there's always going to be a new release, but other stuff, maybe not so much. But on average, we're having to rebuild and test and requalify 30 to 40% of the packages. And we see hopefully that's one of the benefits of a community effort like this. And now I'll just highlight the stuff that we have in the latest release. We did a release for ISC in June. We target 2 base OSes, CentOS and SLES. We've updated for CentOS 7.5. 2 architectures already highlighted, doing builds for ARM and x86. And all the stuff that you see, well, of course, most important down here with the logo, MVAPitch. And the stuff in blue is things that have been added since we were here last time. And you can see it's in a variety of spaces. So things around administrative tools. This is, I think, from you guys, the Node Health Checker. And then we added another containerization, which comes out of the national labs. So we had Singularity before. We just added Charlie Cloud. Several numerical libraries. MFIM is a Livermore finite element library. Some I/O stuff, little things. So just kind of highlights basically how much has been added over the last year. I should mention that all this stuff that requires MPI, which is basically just about everything from here on down, that's where you have to actually do an awful lot of builds. You're building for the compilers, you're building for the MPIs, getting the dependencies right is non-trivial, but you end up with a lot of builds and a lot of things you have to test. So even though this is only 80 some odd components, the net result when you look at all the permutations is we have something like 600 RPMs that are in these repos for x86. Okay.
So,
yeah.
Do you do some sort of testing with these things, like some integrated testing?
We do. Yeah, we have the questions about testing. So we have a test suite. I wasn't going to talk about it today, but I can tell you more. But yeah, we have a test suite, which actually is one of these packages actually up here, test suite that we ship as well. And it's for everything that you see on here, there's a corresponding test. And what it tends to do, for example, let's take PETC. What it's doing is it's going to loop over all of our compiler builds, which might be with GCC, with Intel, loop over all MPI builds, MVAPitch, OpenMPI, MPitch, and run through and test all of those. So you might suspect we're not trying to reproduce all of the testing that the upstream community is doing. It's more integration testing, making sure that it's functional, making sure that we can compile and link against it and run through the resource manager. So for example, this test harness, when we run it today, when we turn it on, it might run 2,000 jobs through the resource manager. But yeah, we do. In the interest of, let me just say one quick thing. So, people ask, is anybody using this thing? Which is hard to say at some point, but we do track, downloads. And I was going to say, we are no MVAPitch with your 485,000 downloads that I looked at on the webpage this morning. That's very impressive. We are not that. But we have seen good, consistent growth in the first few years. So I don't track all the time. I just sort of track on a monthly basis. This is the number of people, unique sites hitting our build server. And it's been roughly doubling every year, so we get about 3,000 folks a month. I just highlighted people this year grabbing Mvapage stuff. So the thing to really hammer home is, of course, you can get Mvapage, which we see people here doing, but you can also get a lot of other packages that were built with Mvapage. So you see Trilinos here, our marathon 14-hour build Trilinos that is very large. We see Python, we see Scorpy, Boost, Petsy, lots of things that an end site might deploy using Mvapage. One thing that we've also started doing is just looking at usage from an architecture point of view. So we first introduced a tech preview of builds with OpenHPC back at SC16. Then we removed that tech preview last year at SC17 once we could actually do bare metal provisioning. So we can now test on ARM and provision the same way we do on x86. Once we did that, we're also starting to track, obviously more ARM systems are starting to come out. So we were just looking at sort of the growth and uptake perhaps in different architectures. So I bin it by two different ways. On the top is based on how much data is downloaded. On the bottom is the number of sites. So, obviously we're still dominated by x86, but you can start to see some ARM downloads and interest in ARM coming, at least from the perspective of the OpenHPC community. And one of the things that we're working on for future release is to do builds with the ARM HPC compilers as well. Okay, so in the interest of time, let me switch to the RPM dependency discussion. So I didn't have a clever app like Adam, but really I'm going to walk you through sort of the pain of having to understand a little bit of what RPM build is doing, and let's just imagine that Alexa sorted this out for us. So as a background, one of the things that we try to do in the community is really to play nicely with what the distro is doing and with what other communities do. So we try very hard to not have namespace conflict. And what I mean is, to your question earlier, Hari, we don't want to install somewhere that somebody else might install from an install path point of view. So we don't install on the /bin, right? We do what you see a lot of in HPC, which is we install into opt, right? And we're in the opt OHPC pod. So we do nice things there. We try to not have conflict in our package names. So for example, we have a standard where all of the packages which come out of our build system, they get a little OHPC on them. That way it's very obvious and we don't conflict with anybody. And we also try to be very proactive in managing dependencies. And this is where it does get complicated because we're doing lots of compilers and lots of MPIs. We try to centralize a lot of this effort. And so we have a macros file. So this is actually straight from an RPM. We're going to start looking at spec file kinds of things. So, right, these are normal semantics for RPMs that calling out, oh, if we're building with GNU 7, obviously we need to have the GNU 7 compilers. Okay, so that's all great. That's well and good. But one thing that you have to be aware of, particularly if you're in the business of sending out binary packages, is that RPM itself does its own dependency analysis. And you can run into trouble. So just if you're not aware of this, one of the things that it does is it scans all of the stuff that's in your distribution for binaries, bin bash, bin Perl. It also scans for .sos, and this is really where the sneaky bit is. So, yeah?
So did you ever try to, because it would have bin bash, did you ever have an issue with building the same package on Debian versus CentOS?
Well,
the location of bin bash is different on the bash is different on those systems.
Yeah, actually we have had a problem specifically with these, but for different reasons, because on CentOS bin bash is actually something, the bash that gets resolved is an alias to bin bash or something like that, and the soft link gets picked up and nobody owns a soft link. So we have had related issues, but our build system mostly takes care of this because we build in that environment, right? So we build in SLES and we build in CentOS, and if they were in different places, we would get different paths here. But the main part I want to focus on is this bit. This is the complicated bit. So RPM is quite rightly trying to figure out, hey, if you're providing a .so, we want to log that. If you build something that requires a .so, we want to log that. Okay, and as an example, I grabbed the Mvapage 2x RPM, right? And one of the things that it provides is libMPI, just like every other MPI stack in the world, right? With a particular ABI number. and that resolves to a path that is not in a default location. Right? And this is very similar to what we do in OpenHPC. Different path, but same issue. Right? So the gotcha is that we've kind of learned that you can't get into problems because of this if you don't install in the default paths. So I'm going to tell you what the gotcha is and how we went around it. So here's an example straight from OpenHPC. So we are building a package that actually also is available from another repository, EPEL, on CentOS. And in fact, multiple packages. So the one I'm going to use here is OpenBLAS. So we build an OpenBLAS using all our fancy conventions. It's named nicely. It doesn't have any conflict with where it installs or its package name. But if you query the metadata for this package to see what it provides, and also from other packages, we see that we have 2 RPMs providing the same .so. Okay? Same with libtool here. So, if someone in our case is using OpenHPC and they're being consistent and using all of the OpenHPC packages, there's no problem. We take care of the dependencies. But the problem that we encountered was, imagine a situation where you kind of do things with a different order of operations. Let's say you installed OpenBLAS from OpenHPC, and then you went and installed things from EPEL which required this .so. You would get this dependency satisfied from OpenHPC, but the linker wouldn't actually be able to resolve it. So what you would get yourself into is a situation where RPM's installed, RPM database is happy, but you just installed binaries that don't work. And that's a gotcha. And so we tried to figure out a way to work around that. And really what we wanted to do from an in-game perspective is we just wanted to add some sort of delimiter to those .sos to differentiate our lib openblas.so from another library. As I'm saying this, think about this in the context of libmpi, right? You want the mvapich libmpi versus, that's right. So this requires digging into RPMs in more detail than you probably care, but quick things to walk away with is RPM's been around for a while, and it has multiple dependency schemas. There's the old way, there's the old foo, which is called external, and there's the new foo. And the thing is that this new stuff, you have a new version of RPM, if you're using any new modern distro, it's going to have these binaries, RPM deps and elf deps. Elf deps is the important one here, that when you do a package build, elf deps is going to scan everything in your package, and that's what's providing these additional dependencies. All right? That's what's adding these into your thing. So, one gotcha here is, in the old days, people used to just hack these scripts to change things, but you can't because it's a binary now. But the good news is that people smarter than me thought, oh, somebody might want to modify this, and there's a plugin architecture. And so just because I thought it might be of interest to this community, I walked through what we did. So new RPM dependency tool has a plugin that allows you to customize the scanning of these packages. And you can do it on a per file type and a per directory basis. The way you do it is by throwing files into userlib_rpm file attributes. And so that's what we do now. We have a package which we require you to install if you want to build OpenHPC packages. That's ohpc build root. And we've dropped some stuff in this directory. And this is really the magic. All of the magic is sitting in this one file. And what this says is, hey, RPM, when you're building stuff, I want you to call something of my choosing when you are in an opt-ohpc path. And I want you to call these scripts that we are providing you. ohpc find provides, and we're going to call them both to give provides dependencies and requires dependencies. Okay? This bit here says I want you to do it for any file that's flagged as an ELF binary, and whether it's 32 or 64-bit. So this is a quick and dirty way to get RPM to call a script that you own to do something. And what we've done is we just use their same binaries to generate the ELF dependencies, and we take that output and we just add a text delimiter at the end of it. Very quick and dirty. All right, so let's see it in action real fast. So I'm going to query RPM from OpenHPC for the GCC compilers. So this was in a previous release that we would have had last year. And you'll notice, this is very standard kinds of provides information that you would get from RPM. Now, once we use with this updated approach, all we've done, there's nothing magic about this is just a text string that has to be satisfied. So you can do whatever you want with it. So all we've done is add ohpc to the end, right? And the assumption here is nobody else is going to do that, right? So this is how we insulate ourselves. So it's very easy on the provide side. Anything that you install into a path that you own, you could, if you wanted to, do something like we are and add a delimiter at the end. So the provides is easy. What's trickier is the requires, because imagine we're building things which do rely a lot on distro provided packages. So we can't just add this string to everything. So we actually have to analyze where these packages come from. We take care of that in the scripts that I highlighted that we enable. And so what that allows us to get is that in cases where it's a .so that is coming from an OpenHPC path, we'll correctly add this delimiter. But if it's something that comes from the distro, from the operating system, we don't touch it. All right? So all these things at the bottom, these are coming from either CentOS or RHEL or SUSE in our case. So we are doing this specifically for OpenHPC, but I highlighted it because you could imagine doing something just like this for Mvapich if you wanted to make sure that the MPI requirements were specifically tied to Mvapich. Okay. And with that, let me stop and say thanks. And I don't know if there's more time for questions. I went just a little over, but thank you.